In this video, we're going to take a look at section 7.1 on solving quadratic equations. Now you might be a little bit confused because we've already talked about solving quadratic equations previously, but in this section we're going to be looking at quadratic equations that we cannot solve by factoring in general. There might be a couple of exceptions to that, but previously we learned to solve quadratic equations by getting 0 on one side and then factoring the other side. But for many of these problems, that won't be possible. So we have to find a different approach for solving these equations. And so the first kind we're going to look at in 7.1 are equations where we can use the square root property to cancel out a power of 2 on both sides of the equation. And so quadratic equations that look like the two that you see here, ax squared plus c equals 0, or a times x minus h squared equal k, we can solve these by just taking the square root of both sides of the equation. So we won't be factoring to solve it, even though these are technically quadratic equations. We'll just get x squared by itself, or maybe not x squared, it depends which version of the equation we're dealing with, but get the square thing by itself, and then take the square root of both sides, and that cancels out that power of 2, and then we should be able to solve for x after that. So that is the game plan. So isolate x on one side of the equation using a square root to cancel out the power of 2. That's the general strategy that we're going to take with these types of quadratic equations. Remember that when you take the square root of both sides of an equation, you must apply a plus or minus to one side. So this is a detail that's really easy to forget. The reason we have to do this is because we talked about this back in 6.1 a long time ago, and then we didn't really do much with it, so you probably have forgotten. But whenever you actually simplify something like this, like the square root of x squared, it isn't just that the square root cancels out the power of 2, and we get x. Remember, there was the issue of this side is always positive, so this side needs to always be positive. And since it isn't automatically just always a positive number, we have to make sure it is by using absolute value. Right? So if we're trying to solve an equation like this, like x squared equals 9, for example, we can take the square root of both sides. The square root of 9 gives me 3, but the square root of x squared is actually not just equal to x, but the absolute value of x would be the proper thing to put there. And then solving that for x, we actually get two answers. We get x equals positive 3, and x equals negative 3. There's two solutions to this equation. Right? The thing is, nobody really wants to deal with the absolute value. It's really just something we'd rather not have to think about or to work with. And so in lieu of using this absolute value, we just use a plus or minus symbol. So the way most people are going to do this equation is they'll take the square root of both sides. Instead of using absolute value over here, we'll just call that x, because that's just how we want to think of that. But in exchange of not using the absolute value here, I have to put a plus or minus on the other side of the equal sign. So this will be plus or minus 3, which gives me the same two answers that I got up here. Right? And so that's the math behind why we have to do the plus or minus. So just remember, anytime you take the square root of both sides of the equation, to apply a plus or minus to one side of the equation. Usually the side opposite of the variable. All right, so let's take a look at some examples. All right, so give the exact solutions and approximate solutions to 3 decimal places when appropriate. All right, so to solve this equation for x, it's a quadratic equation, but this cannot be factored, right? It's already equal to 0, but this part here cannot be factored. I still look into that possibility because if you can solve it by factoring, that is usually the easier thing to do. But this cannot be factored. So we're going to have to use the game plan we just set up, which is let's solve for x, get x by itself on one side of the equation, and whenever we run into the power of 2, we'll use a square root to get rid of it. So the first step here would be to add 7 to both sides. All right, so we'll get 2x squared is equal to 7, right? Because we're trying to get the x by itself, so we're moving everything to the other side of the equation. To get rid of the 2, we'll divide by the 2 on both sides. That'll be the next thing we want to do. And we'll get x squared is equal to 7 halves. And now, to get the x by itself, I want to cancel out that power of 2. So I'm going to apply a square root to cancel out the power of 2. If I do that to the left-hand side, I have to do the same thing to the right-hand side. Right? And then the power of 2 cancels out with the square root, and we just get x. Again, mathematically, technically speaking, we should get the absolute value of x, but I'm not going to bother using absolute value. Instead, I'll just use a plus or minus symbol on the other side of the equation. So I'll put plus or minus here, the square root of 7/2. All right. Unfortunately, we can't leave our answer in this form because we learned about this in chapter 6. You don't want to leave radicals in the denominator. And I know that doesn't look like a radical in the denominator here, but what we really have here is x equals plus or minus the square root of 7 over the square root of 2, right? That square root applies to the top and the bottom of this fraction. So we actually do have a square root in the denominator, and so we need to rationalize the denominator. So we will multiply a square root to the bottom, so not just a square root, but square root of 2 to the bottom, right? Multiply it by a copy of itself. Right, so square root of 2 times the square root of 2 just gives me 2, and that rationalizes the denominator. Since that works, I'll go back and do the same thing to the top, multiply square root of 2 to the top, and we get square root of 7 times the square root of 2, which will be the square root of 14. And so this would be the answer that you would want to type into Math Excel. This is the exact answer. All right, so I wanted exact solutions. That means keeping the radical in there if it can't be simplified, which in this case it can't, right? Square root of 14 cannot be simplified. The approximate solution means plug it into your calculator and get some decimals for it. So I made sure to have my calculator handy here. So I'm going to plug in square root of 14. So let me go ahead and type it in here. 14, take the square root of that, and then divide it by 2. And I get 1.871. When I go to 3 decimal places, right? 3 decimal places. Really was a 0 here, but then the next number over was an 8, so I'm rounding it up to a 1, right? And so then, again, it's still plus or minus. There's still 2 solutions here. And this would be the approximate solution. All right. Let's look at another example. All right, so here we have give exact and approximate solutions to 3 decimal places. This one will not actually need to have an approximate solution. You'll see why here in just a second. So this time, again, I want to get x by itself. I do want to get rid of the minus 5, but I can't yet because it's stuck inside the parentheses because of this power of 2. So the first thing I will have to do with this equation is cancel out the power of 2. What cancels out a power of 2? A square root. All right, so we apply square root to both sides of the equation first this time. The square root cancels out the power of 2, and we'll just get x minus 5. Again, officially, I don't know how to say this. In reality, what we get is an absolute value of x minus 5, but I don't want to do absolute value. Instead, I'll just put plus or minus on the other side of the equal sign. So plus or minus the square root of negative 16, which can be simplified further. So remember, a negative inside the square root comes outside the square root as an I. So we'll get I times the square root of 16. And then the square root of 16 is going to simplify to 4. And so what I end up with here is x minus 5 equals plus or minus 4i. All right, we'll put the 4 in front of the I. And then to get x by itself, we'll add 5 to both sides. Now you got to be careful here because there's a plus or minus. The common thing most people do is if you're bringing something else over where there's a plus or minus involved, you put it in front of the plus or minus. It just looks better that way. I don't know if that's true in reality. It's just what I'm used to, but that's the way everybody's kind of trained to do it. So if you want to make sure you're presenting the solution in a way that most people are expecting, then you want to put the positive 5 in front of the plus or minus. So we have positive 5 plus or minus 4i. These are not like terms. So because 5 does not have an I, 4 does have an I, so they're not like terms. So we cannot do anything to simplify this. So we will just leave it the way it is. And you can just leave it here with the plus or minus symbol. Math Excel has a button that you can click to add the plus or minus symbol to your answer. And that's just what I would use here. And this cannot be approximated by plugging it into your calculator because the numbers are already nice numbers and it's a complex number. It's imaginary. So there's no plugging it into your calculator anyways. So when it asks you to find the approximate solution, that's, as the last one said, if appropriate, right? When appropriate, find an approximate solution, it is not appropriate to do so here because there's just nothing you can approximate. It's already, it's exact, and there's no way to, it's exact and it looks nice the way it is, and there's no way to plug it in your calculator to get something else. So, all right. Okay, so this one we will be able to approximate. So same situation as last time, except this time we won't get imaginary solutions. We want to get x by itself. I want to get rid of the minus 12, but I can't do that yet because it's stuck in the parentheses. I have to first get rid of the power of 2. I will do that by taking the square root of both sides of the equation. The square root cancels out the power of 2. I'll just get x minus 12 equals, don't forget your plus or minus here, the square root of 45. All right. And then to get x by itself, I will add 12 to both sides. That 12 we'll go ahead and put in front of the plus or minus. And so we get x equals 12 plus or minus the square root of 45. Now the square root of 45 can be simplified. I could have started working on it already. I just kind of wanted to take one thing at a time. But remember back from chapter 6, we talked about how to simplify square roots. You're going to split this up. And for 45, the best way to split it up is 9 times 5. You apply the square root to each number separately. The square root of 9 gives you 3. The square root of 5 copies down. The plus or minus copies down, and so does the 12. All right. So this would be our solution to the equation. This would be the exact solution. But this is one we can plug into our calculator, right? So if you have any, I guess a good way to tell if you can approximate it is if you have any radicals in your answer, you should be able to approximate those by plugging them into your calculator. Our last problem did not have any radicals, so there was nothing to approximate. Here we can approximate the square root of 5 by plugging it into our calculator. So I'll take the square root of 5, that's 2.23606 ... just keeps going. I'm going to multiply that by 3. And so I'll get 6.708203 ... Now here we got to deal with the plus or minus. So let's go ahead and write it up here for the approximate solution. We'll have 12 plus or minus the 6.7082. Now you want to make sure you need 3 decimal places here, so that should be enough, but I'll go a couple more. 0, 4. We'll round that to 4 right there. It was a 3, but there's a 9 after it, so I'm going to round that up to 4. So that's what we get from 3 square root of 5. All right, we get this number here. Now I want to take 12 plus that number and 12 minus that number. So again, whenever you use the plus or minus, there are 2 answers. There's one answer where you use the plus sign. Whoops, kind of put too many 8s in there, it looks like. Let's try that again. 7, oh, that's supposed to be a 0. 08204. So that's one answer using the plus sign. And we have another answer using the minus sign. 204. All right. So if I add these together, I think that case is a pretty easy one that you don't really need a calculator for. You'll just take 12 plus 6, which is going to be 18, and then the decimal part's just going to stay the same. All right. To subtract it, what I'll do, since I already have this number in my calculator, I'll do minus 12, which is backwards, right? It really should be 12 minus that number, but I'm taking this number minus 12 in my calculator, and then I'll just remember to take the opposite sign. So my calculator tells me negative 5.2917, but I know this should be positive. So I'll have positive 5.29179.6. Okay, I'll go that far with it. All right, and then we want to round each of these to 3 decimal places. So I'll round it to here. So this will be 18.708 as one of my answers, and this will be 5.292 as my other answer. All right, and so those would be the 2 approximate solutions for this problem. All right, now we could have done the same thing with the last problem. Again, there's 2 answers here. We have 5 plus 4i, right? One answer where we use the plus sign, and we have 5 minus 4i, one answer where we use the minus sign. And by splitting it up, I mean, you can write the 2 answers separately, but nothing is really gained from that because again, these are not like terms. You can't add these together. They're just going to stay the way they are. And so since nothing really simplifies by doing that, we just leave it with the plus or minus. All right, so same thing here with the exact answer. There's no benefit to splitting that up because you can't simplify it any further. But when we do the approximate answer, we do need to split it up because we need to see what happens when we use the plus sign, what happens when we use the minus sign. We get two different answers from that. And by approximating it, we can combine these together, right? As a radical, these do not combine together. But as decimals, yeah, we can go ahead and combine those together. So we split it up, look at the plus case separately, look at the minus case separately, and see what two answers we get. All right. So the next type of problem in this section is still going to involve using a square root to solve the equation, but we have to do a lot of setup to make that possible. And the setup we'll have to do is what's called completing the square. All right, so this is another kind of quadratic equation, and this actually will solve any kind of quadratic equation. It doesn't have to be set up in any special way. Any quadratic equation can be solved by completing the square. All right, the first step is to get the equation into the form x squared plus bx equals c. So you want your first two terms on the left-hand side of the equation, and then the third term, you just want to move it out of the way by putting it on the right-hand side of the equation. So you have the x squared term on the left-hand side, the x to the first power term on the left-hand side, and then the number that's by itself, put that over on the right-hand side. Then you take b, divide it by 2, and then square it, raise it to the second power. This is going to tell you the magic number that you need to add here so that this will factor as a perfect square. So it will factor as one thing raised to the second power. So let me use some different colors here. That's kind of all blending together. Okay, let's do that. Okay, so by step 2 is going to tell me what number to add to the left-hand side so that this thing here, when I factor it, will factor as one thing to the second power. That's what it means to be a perfect square. And if we can factor it this way, then we can solve it by taking the square root of both sides to cancel out the power of 2, and then we can solve for x, just like we were doing with the previous couple of examples. Excuse me. All right, so step 2, follow this process, find b, divide it by 2, raise it to the second power, add this result to both sides of the equation, because if you're going to add it to the left-hand side, you have to also add it to the right-hand side. So whatever we're adding over here, we got to add the same thing over here. Then we can factor the left-hand side as a perfect square, as I just mentioned. And then once we have the equation set up like this, you'll have x here, and you'll have, some number here, plus or minus, depends on what the situation looks like, squared. Then you can solve this for x by taking the square root of both sides, adding or subtracting that number out of the way, and you get x by itself. All right. So solve using the square root property just like we were doing on the previous problems. All right, so let's take a look at an example. All right. So this one's already set up for us the way we need it to be set up. So step 1's already done. We have x squared plus 2x. What I like to do is leave an empty space here for the number that I'm going to want to add to the left-hand side to make it factor the way it needs to factor. All right, so I'll leave a space here so we can add that number in. So step 2 is to take b, which in this case is 2. So b is equal to 2. Divide that by 2. Right? So we'll get 1. And then raise it to the second power. And so it still comes out as 1. All right? So take b, divide it by 2, and then raise it to the second power. When we do that for this problem, we get 1 as our magic number that we need to add here so that this will factor as a perfect square. If I add 1 to the left-hand side, I have to also add 1 to the right-hand side. I have to balance that out. All right, so this was step 3, adding this number to both sides of the equation. Step 4 is to factor this as a perfect square. So how is this going to factor? Well, what two numbers multiply to 1 and add to 2? The answer is positive 1 and positive 1. All right, those are two numbers that multiply to 1 and add to 2. Because we get the same factor twice, this is really important that you write it this way. Otherwise, you're not going to be able to complete this problem, you want to write this as x plus 1 squared. Because you're getting the same factor twice, write it as that factor squared equals the right-hand side here, which is 14. So we'll go ahead and copy that down. Right. So that's step 4. Factor it as a perfect square. Make sure you write it as a square. And then step 5 is now you should be able to solve this equation using what we learned earlier in this section. So first we'll cancel out that power of 2 by taking the square root of both sides. The square root cancels out the power of 2. We get x plus 1 equals, don't forget, I know there's a lot of other stuff going on in this problem, but you have to put the plus or minus there whenever you take the square root of both sides. And then we will subtract 1 from both sides to get x by itself. We'll put the minus 1 in front of the plus or minus. That's usually the way it's written. And so we're going to get x equals negative 1 plus or minus the square root of 14. This square root doesn't simplify in any way. These would not combine together, so we'll just leave it as a plus or minus. We don't have to separate the answers into two different expressions because nothing simplifies even if you do that. And it doesn't ask us to approximate this time, so I don't need to bother with plugging this in my calculator. We're just going to leave the answer like this. All right. And so that's how the completing the square process works. A couple of things that will give us a little bit more of a challenge is if b is not divisible by 2, you'll get a fraction here. That's going to make things a little more difficult. And also, if the numbers aren't as cooperative, it might be hard to figure out how to factor it. So let me just go ahead and tell you the shortcut here while the numbers are nice and simple. Whatever number you get here from step 2, no, it's not that number. Sorry, I'm pointing to the wrong thing. Whatever number you get before you square it, it confused me because it's the same number in both cases, right? They're both 1s. But you want to look here. Whatever this number is, that's the number that ends up being the number in the factor. So the number before you square it is the number that you will get inside the factor when you go to factor the left-hand side. It'll be x plus whatever this number is as your factor. Sorry, let me do that circle one more time so you can see it a little bit better. Okay. So just in case we might need that on the next problem or two. All right. We won't need it for this one because, again, the numbers work out pretty nice. Now, the first thing I would do here is get the 4 out of the way, right? The 4 is not part of the completing the square process. It's just going to get in our way. So let's just add the 4 to the other side. We get x squared minus 18x. Leave a space for the magic missing number that you're going to want to add here for this to factor as a perfect square. All right, so that's step 1. We just added the 4 to the other side and leave a space for the number that we're going to be adding. I'm having trouble talking for some reason. I'm having trouble saying that part. I'm doing okay with everything else, but just that sentence I'm having trouble with for some reason. All right, so that's step 1. I'm not even going to try to say it again. So step 2, we're going to take b, which is negative 18. And we got to do 2 little things to it. We have to divide it by 2. So we get negative 9. And then we're going to square that. And so we get positive 81. That's the magic number that we need to add to the expression on the left-hand side so that it will factor as a perfect square. So 81 is what I want to add to the left-hand side of this equation. So this is step 3. We're going to add 81 to the left-hand side, so this will factor as a perfect square so that I can solve this equation. If I add 81 to the left-hand side, I have to add 81 to the right-hand side to balance that out. All right. So on the left-hand side, I'm going to factor this, and again, these numbers are nice enough that we can factor it like usual. 2 numbers that multiply to 81 but add to negative 18 will be negative 9 and negative 9. So this will factor as x minus 9 times x minus 9, which I will want to write as x minus 9 squared. The right-hand side, we'll just add those numbers together. We get 4 plus 81. That'll be 85. Right? And then we'll solve this equation. So I guess let me enumerate my steps a little better here. So step 4 was factoring. And then step 5 is solving this equation. So we'll take the square root of both sides. We'll get x minus 9 equals plus or minus the square root of 85. We'll continue up here. Let me see if I can go ahead and fit the last step. There's just one more step here. We're going to add 9 to both sides to get x by itself. So we'll get x equals 9 plus or minus the square root of 85. You should think for a moment, could I simplify square root of 85? So you could split it up. You could try to split it up. What numbers do we want to try to get here for a square root? 4, 9, 16, 25. Those are the target numbers that you would like to see with a square root, but none of those numbers work, which means square root of 85 is not going to simplify. And so we'll just leave it the way it is. All right, so that would be our final answer. All right, again, notice the pattern I pointed out in the last example. The number that you have here before you square it, it's -9. That's the number that shows up in the factor, -9 here. That happens every time. It's really going to, you need to know that in case we get fractions, because if you get fractions, you're not going to be able to figure out how to factor it the usual way. So you want to know this shortcut. Go back to this. What number did I have before I square? That's the number I want to put inside of my factor. All right, so let's look at another example. Maybe not. I could be wrong. Maybe we're not going to have fractions. Maybe I was nice enough to make all these problems where they all work out with nice numbers. So this one's even easier than the problems that we were just doing. And I think I was trying to figure out, as I was looking at this ahead of time before I started recording, why is this problem here at this point? And I think I put it here for my class to try. So when I'm teaching this face-to-face, I think, because I'm kind of near the end, that this would be a good problem for you guys to practice. Except that you don't want to do the full completing the square process because half of it's kind of already done for you, right? They already have the 9 over here by itself. That's step 1. They already took b, which is 8, divided by 2, which is 4. Square it, you get 16. They've already added the 16 here for you. And so we have to assume they've already added it to the other side as well. So you don't have to add the 16 over here. They've already taken care of all that for you. So whatever was here before, they already added the 16 to it, and that's how they got 9. And so you're already past step 3. All you have to do is the last 2 steps. Factor the left-hand side as a perfect square, and then solve the resulting equation. And this time they want you to actually plug it into your calculator to approximate, if you have to, which I don't think you will have to approximate here either. So again, when appropriate, I think these numbers are actually going to work out pretty nice. So I was going to suggest that you try this problem by pausing the video and seeing if you can figure out how to factor this as a perfect square, how to solve that equation that you get once you do that, and then resume the video to see if you were able to get to the solution that you were supposed to get. So this will factor as 2 numbers that multiply to 16 and add to 8. It'll be +4 and +4. And we will want to write that as a square. So we'll write this as x plus 4 squared equals 9. And then we'll solve this equation by first getting rid of that power of 2. We'll take the square root of both sides. We get x plus 4. The square root cancels out the power of 2. And then square root of 9 is 3. But you also didn't forget the plus or minus, did you? So it's a very easy detail to overlook. So you have to always be vigilant thinking about that. When I take the square root of both sides, you need to put a plus or minus there, regardless of what is happening with that expression. Whether it simplifies nice, whether you get an imaginary number or a square root as a result, plus or minus has to go there, right? So we put a plus or minus there. And then we will solve this for x by subtracting 4. And now I kind of think I see why I put this problem here. Maybe it wasn't for my students to try. It was maybe for this reason here. So for most of our problems in this section, we have left the answer with the plus or minus symbol in it. You don't want to do that here because these can be simplified further if we look at the plus case and the minus case separately. These numbers are like terms. The 4 and the 3 will combine together if we look at the plus case separately and the minus case separately. So since we can simplify it further by splitting this up into the plus and minus case individually, we need to go ahead and do that. We want to have the answers as simplified as possible. So we don't want to leave it with a plus or minus symbol if we could simplify it down to just a single number in both cases, which is what's going to happen here. So we will look at the plus case, -4 plus 3, And we'll look at the minus case, negative 4 minus 3. Negative 4 plus 3 gives me negative 1. That's a much better answer than leaving it like this. And then negative 4 minus 3 will be negative 7. And so if you made it this far, that's great. That's exactly what we were doing earlier, and I'm glad you were able to get to that point. But in this particular problem, you really want to look at the plus and minus case separately because you can then simplify it even more. And this is the way you want to type your answer in the Math Excel. So you just have two answers, two numbers, negative 1 and negative 7. All right, let's take a look at this last example here. Now this one has fractions, so I thought I would have put at least one of these on here. So we will definitely want to use that shortcut I was talking about earlier. We're going to follow this by, or sorry, not follow this. We were going to solve this by completing the square. And so it's already set up for me the right way. So step 1 is already done, right? You already have, I'm going to rewrite it though. We have m squared minus 25 over 2m. And I'm going to leave a space. See if I can say the sentence right this time. I'm leaving a space so that we have room for when we add the number that we need to the left-hand side of the equation. We'll have a space to add it right here. So I know that in a moment I'm going to be looking for this special number that when I add it to this will make this factor as a perfect square. So I'm leaving a space for that special number. And then we'll have 5 halves over here. All right, so that's step 1. Step 2 is to take b, which in this case, unfortunately, is a fraction, negative 25 over 2. So this is step 2. b equals negative 25 over 2. We want to divide that by 2, right? And so I would think of this as 2 over 1. Dividing by 2 over 1, it's a fraction, so we will multiply by the reciprocal, 1 over 2. Right? So if we're dividing by 2 over 1 and you think of that as a fraction, to divide by a fraction, you multiply by the reciprocal. And so we're going to get negative 25 over 4, right, when we divide that by 2. And then we have to square it. And so we will get a pretty big number here. We're going to get 625 on top over 16 on the bottom. So when you square a fraction, you square the top, you square the bottom. And that's what you get. So this is our special missing number that we need to add to the left-hand side to make this factor as a perfect square. So I'm going to add 625 over 16 to the left-hand side. I will do the same thing to the right-hand side to balance that out. And then, so this is step 3, right? Step 3 is to add that special number to both sides of the equation. Step 4 is to now factor the left-hand side. Now here's where we have trouble, because here you're not going to be able to think of two numbers that multiply to 625 over 16, but add to negative 25 over 2, right? They're fractions. It's just a difficult question to answer. So instead, what I'm going to use is the shortcut that we just talked about on the last couple of problems. I'm going to go over here to before I squared the number. This thing right here, that's the number that's going to end up inside of the factor. So it's negative, so I'm going to have minus 25 over 4. If it was positive, I would have plus 25 over 4. And so that's how this will factor. So go over here to the number before you square, grab that number, put that number as the number that goes in your factor on the left-hand side. On the right-hand side, we want to add these two fractions together, so I need a common denominator. So that'll be 16. So I'll multiply the top and bottom here by 8. So we'll get 40 over 16 plus 625 over 16. And those will add together. I was hoping to have enough room here, but I kind of don't really. So it'll be 16 on the bottom, and then 40 plus 625 will be 665. All right, and so that's what that'll equal. And now we can solve this for m by first getting rid of the power of 2. So I'm going to take the square root of both sides of the equation. So we'll get m minus 25 over 4 equals plus or minus the square root of 665 over 16. All right. Now we will solve for m. We'll continue up here by adding the 25 over 4 to the right-hand side. So we'll get positive 25 over 4 plus or minus the square root of 665 over 16. So again, what I'm doing there is I'm adding, again, I'm out of room, but I'm adding the 25 over 4 to both sides of the equation to cancel out the minus 25 over 4. And then I'm going to put that number in front of the plus or minus like we've been doing all video. Then we can simplify this by applying the square root to the top and bottom of this fraction. So we'll get square root of 65 over the square root of 16. And then the square root of 16 simplifies. So we'll get m equals 25 over 4 plus or minus the square root of 665 over 4, which gives them common denominators, which would be helpful if these actually could be added together. But they're not like terms because this one has a square root, this one doesn't. So there's no need to split it up into the plus case and the minus case separately. So I think we'll just leave the answer like that. And I'm pretty sure that this square root of 665 doesn't simplify. I'm just trying to think of some numbers off the top of my head that might work, but I can't think of anything. So, 4 doesn't work, 9 doesn't work. I don't think 16 would work if 4 isn't going to work. 25 doesn't work. 36 doesn't seem likely. 49. Yeah, I just don't think any numbers are going to come out of the 665. So pretty sure that's going to be the final answer. All right, so that concludes the video on section 7.1 on solving quadratic equations by using the square root property.